Hello, everyone, and welcome to Beyond Bandwidth, Leviton's podcast series where we dive into network technology's hottest topics. I am your host from Leviton Network Solutions, Roy Chamberlain. This season, we delve into extended distance over copper. Today, in our first episode, Todd Harpel and I will review what extended distance over copper is and how it is being defined in our industry today. All right, welcome, Todd.
Thanks for having me.
So we're season 3 for Beyond Bandwidth, and we're talking about extended distance over copper and other solutions that will get us to those distances over 100 meters. Very excited to have you as our guest host for this season. Can you tell us a little bit about your background, what you do for Leviton and any other affiliations you have in the industry?
Sure, yeah. So I've been working here in New Holland for Berktech for 25 years, actually. And we were acquired by Leviton back in 2020. So part of the Leviton family now for the last 5 years. And I am currently in charge of copper cabling solutions, cable and connectivity in North America, and the connectivity for the world, really. Product managers work for me, and the product managers for our copper cable work in New Holland here for me as well. I'm also a member of the TIA TR42 committees that set the standards for our industry, and I attend the copper portions of those committees that are working on different copper solutions. And I am also the communications chair for the Connectivity and Cable Association, CCCA, in our industry as well.
Wow, great. You definitely help us to understand what those standards are coming up. So those are some important affiliations when you talk about our industry. So it's good stuff. So extended distance over copper, can you tell us a little bit about that and what exactly does that mean?
Sure. When we talk about extended distance, we're talking about supporting devices and applications that are longer than what our industry standards, the TIA standards, currently specify, which is 100 meters. So that 100-meter distance specification came about back in the early days of the 568 standard, and it was centered around some of the capabilities of the technology that was in place at the time with different computer communication systems and that type of thing. And the 100-meter distance was settled upon that you could now have both the people that were making the cables, the connectors, the patch cords, and the systems like that give a very specific electrical performance to IEEE, who are the group that developed the standards for the actual transmission equipment. So
Okay.
IEEE develops all of the different Ethernet specifications for all the different Ethernet speeds, not only copper, but also fiber. So you needed the ability to give them a predictable electrical transmission media performance so that they could build all of the transmission equipment around that and know what things like noise were going to look like, things like transmission delays, and those kinds of things were going to look like so that they could properly design the equipment.
All right. What is the history here? How did we get to this current extended distance over copper thing that's seems like it's kind of gone viral over thin air? I mean, I've always heard of different applications and different distances that are touted from manufacturers for kind of in between. Let's say like category 5E or 6 is for 1 gig for 90 meters or 100 meters channel. And manufacturers will give other types of options where you can use them for different applications that might not be that specific, right?
Sure.
So what about the history of this? How did this all of a sudden just break out within these last couple of years?
Well, it's kind of funny because I've been in the industry long enough to remember when there were different communication protocols for different computer manufacturers. So IBM was different from Digital Equipment Corporation, was different from WangNet, and actually every one of them had their own cabling system and actually had their own distance capabilities, which were not 100 meters. Some of them were much longer. And then when we finally came out with the first 568 standard, then we finally had a standardization on this 100 meters. And then a few years ago, and it's actually been a number of years, we would have, as part of the industry, we have warranties on our cabling system, and we would get test data from some of the installers
Uh-huh.
who would send in test data that had links that were slightly longer than 100 meters. And that usually happened by accident, where the pathway they used to reach the station at the other end was a little bit longer, or they had to route around an obstruction, and the
Uh-huh.
cable got to be a little bit longer than that they had planned. And a lot of times they would say, "Hey, can't you just warrant it? It's still past most of the other parameters except for length." It would still pass crosstalk, it would still pass attenuation, those kinds of things. And often they would even try to set up the equipment at the other end and it would work. And we had companies come to us and say, "Hey, we're using one of your high bandwidth category sixes at the time, our Landmark 2000." And they would say, "Hey, it worked. We were able to support this IP phone, out there at 106 meters." I'm like, "Yeah, yeah, that can work." But then a couple years ago, we started to hear from different manufacturers who were starting to tout some pretty extraordinary distances beyond 100 meters. It wasn't just, 5 or 6, it was double the distance was their claim. And often the evidence that they were giving was a single test with two specific devices that actually were able to make a connection at a really long distance
Yeah.
as proof that everything would pass. And the reality is, that's not necessarily the case. But there are a lot of people out there that say, "You know what? It's a lot cheaper to run a copper cable and hope that it works than to put in another communication closet, or even a remote switch somewhere in a cabinet, where you have to get power out there. You've got to do a lot of things to be able to support that, which is very expensive. Just running a piece of cable to that remote device is a cheaper option, and they would rather take that and even take the chance of it working than just kind of do it what we would consider have at the time the right way."
Right. Yeah. So you brought up a really good point, and I remember this, and it's a question that comes up. It's like, okay, well, I have my tester on the cable. It's beyond the 90 meters or 100 meters, whether I'm doing channel or basic permanent link. And like you said, I have headroom and I meet or exceed all the parameters except for length. Can you explain why the tester has everything passing, but the length is what limits it? Can you just explain why that limitation causes us to get that failure, even though all the electricals on the tester that it's going through don't seem to pass?
Well, the primary reason that it fails is the tester's programmed with a pass fail based on the actual length, right? So that tester's settings are going to say, up, it's too long, therefore it's not going to pass.
Right.
However, as an industry, built cables and connectors and patch cords that are better than what industry standards actually require, right? So we've
Mhm.
put in extra copper, we've put in extra noise suppression in the crosstalk and alien crosstalk and those kinds of things into our cables. And that's just kind of part of our industry differentiation process. And part of that was to help mitigate maybe external environmental factors, or
Right.
at times even installation practice that may have been substandard. It could actually compensate for that and make things easier to pass. That's why you're seeing some of the rest of the parameters besides length still pass for the TIA standards.
Okay. That's a good explanation. So you mentioned your role in the TSB 5073 as part of the TIA committee that you're involved with. Can you kind of expand on what your role is and, some of the conversations and debates that are going around in those meetings?
Yeah, the TIA TR 42.7 committee has been looking at this whole issue of extended distance, recognizing that the industry is doing something outside the scope of the standards, and realizing that, we are the representatives of the industry and need to inform our readers of our standards and the user community on what's going on. So there was a task group formed to look at this, and I was part of that task group at the time. This was in 2024. We started looking at what should we be doing and started saying, well, maybe we should write a technical services bulletin, or a TSB. The task group started looking at what should be included in this TSB. At the beginning, we didn't even have a number. We just started accumulating contributions from various companies within our industry. In the middle of 2025, we finally got TIA to assign a number, and that's TSB 5073. And now the editor of that document, it's still in a task group format. What that means, according to the rules of TIA, is as long as it's a task group, what we can do is almost anything. We can add,
Right.
delete, we can rearrange, we can do anything we want to the document without taking any votes or anything like that to get it finally to a position where we want to literally start a formal process with the document where you submit it for what's called a ballot. And then at that point, it's locked into pretty much the place that, or the way that you want it to be arranged. And then it can only be changed with industry consensus. So right now, that's where we are. It's still in task group form. I am completing the final version that's going to be submitted to the committee in February's meeting of next year. And at that point, we'll send it out for the first ballot, they call it. And that first ballot will give everyone that is in the TR 427 committee the
Yeah.
opportunity to start submitting comments and doing technical changes or editorial changes or those kinds of things. And all of those have to be considered, and you have to reach consensus with the committee members before any changes can be made.
Okay.
As far as the discussions and conversations, there's a couple things I'd really like to mention. Number one is that a TSB is only technical information. It is not a standard. And a lot of people get that confused, right?
Yep.
A TSB will never have the word shall or must in it. Everything in the TSB is a recommendation. So you can't really design a standard with only recommendations, right? All of your regular standards say it shall be this, the length shall be 100 meters, or the near end crosstalk shall not exceed X at this frequency, those kinds of things. So a TSB, we have to be really careful. It is basically a explanation and technical information of what you need to know if you're going to do something that is actually outside the scope of a standard.
Right. Like an exception to the rule kind of thing.
Exactly. I like to remind people of the early days of 10 gigabit Ethernet. There was a TSB called TSB 155 that said, hey, if you want to try to run 10 gigabit Ethernet over existing category 6, here are the things that you need to be aware of. Now, we all know that 10 gigabit Ethernet is actually designed to operate over category 6A, but it is possible to run a few links that are shortish distance, right?
Yep.
55 meters, those kinds of things. So it's recommendations for what to look at, but it is not a design standard. So you can't design a cabling system around a TSB.
Okay. All right. So I'm curious, and I've seen the history myself, and I feel like we've done everything to siphon every drop of potential out of twisted pair cabling, right? Is there a movement towards fiber with power conductors versus just trying to keep extending twisted pair? I mean, what's your understanding or experience on why we keep pushing twisted pair when it seems like fiber and a higher gauge copper might be an easier way to get those performance and mitigate voltage drop, things like that?
Well, the short answer is it's cheaper, right?
Okay.
Depending on how far you want to go, using a copper twisted pair cable tends to be less expensive than trying to use another alternative like optical fiber with transceiver that you can go much further than any copper cable could go, right? You can go kilometers with optical fiber rather than just the few hundred meters that you can with copper. But the cost of doing that, and you mentioned a hybrid cable that has copper conductors in with the fiber to carry the DC voltage often associated with the transceivers.
Mhm.
Those are great options when you have much longer distances to go where you would not be able to reach that with a twisted pair copper cable. But within a certain range,
Yep.
somewhere around 155 to 200 meters, depending on your application and the amount of PoE power you want to send, copper cable tends to be a much less expensive option for that deployment than using optical fiber.
Okay. How is Leviton addressing extended distance needs today? Like, what is in store in the future from Leviton on extended distance over copper?
Yeah, today we have a solution that is based on our SST Category 6A cable, and it's actually a global solution. Our factory in Europe also make the same cable and has the same capabilities, and we're able to support 140 to 155 meters, depending on what PoE power level you want to send. Then I would say there are several other companies in the industry that have similar type of capabilities in terms of their specific cabling being able to go in that range. So we support that with our SST and our Atlas X1 connectivity today with a guarantee, with a warranty for that. We're pretty excited about that. And there's still some things out there in terms of copper cable technology and cable designs that we're exploring that hopefully will get us even longer capability. We're pretty excited about some of the things that we've observed in some of the trials that we've done. And it's interesting to me that the technology is being stretched, but it's an exciting time to be in our industry right now because
Yeah.
we're all looking for ways of giving our customers really what they want. We have some very large end users that have been very interested in some of these capabilities and are starting to deploy them in some pretty significant opportunities around the world because they recognize the cost savings that they're going to have by not having to add transceivers with fiber or extra closets or extra cabinets, those kinds of things.
Yeah. Yeah, no, that's good. And it is exciting. It seems like a lot of new things have that are used that need to be used, right? A lot of the demand in the industry has created some excitement in our portion to be able to address what the demands are of the clients and the technologies. So now we're kind of doing this introduction here for our first episode. What can the audience expect to learn from this season of Beyond Bandwidth?
Yeah, we've set up some pretty great guests for the podcast. We wanted to look at this topic from a number of different perspectives. So we have a consultant who does designs for their clients. We have a tester manufacturer who's going to give us some details on what they're seeing and things like testing of these extended distance channels. We're looking at other types of guests that have actual experience with either the use of or the deployment of these types of systems. And, we wanted to make sure that all of the perspectives were given fair airtime. You will hear, in some cases, people kind of saying, you know what, at the end of the day, we still recommend that you go within the scope of the standards, which is 100 meters. But
Yeah.
from my perspective, that's still sound advice, but there are still going to be opportunities to go beyond that and maybe deploy a limited number of channels that are outside the scope of that 100 meters.
Well, that's great. Well, thanks, Todd. This has been a great start to the season and look forward to working with you and listening to some of the episodes and guests that we're going to have coming up. I think it's going to be a good one.
You bet. Great to be here.
Beyond Bandwidth is a podcast series produced by Leviton Network Solutions. For more information on the topics we talked about today, as well as other enterprise or data center network infrastructure content, or to check out all available episodes of Beyond Bandwidth, visit us on the web at leviton.com/beyondbandwidth, or wherever you normally listen to podcasts. If you enjoyed this episode, we'd appreciate you leaving an honest review in your podcast application. Along with word of mouth, leaving a review will help others find our show. I'm Roy Chamberlain, and this was Beyond Bandwidth. Until next time.